Hello, my name is Michał Sochański. My paper, Experimenting with Diagrams in Mathematics, has two aims: to propose a distinction between two classes of mathematical diagrams, or a way of understanding differences between them, and to argue that some uses of diagrams from one of the distinguished classes can be construed as a specific kind of an experiment. Distinction is based on how spatial properties of diagrams relate to conceptual content they refer to, and on how this content is assigned to diagrams. Diagrams of the first class represent mathematical concepts that originate in some idealization of spatial properties of physical objects. Typical examples include concepts of geometry or topology. In this case, analysis of spatial properties precedes conceptual analysis. What is more, topological properties of those diagrams denote actual topological properties, which are of course idealized or conceptualized in different ways and to a different degree. Diagrams of the second class are constructed in order to investigate non-spatial mathematical concepts by translating some of their properties into a selected spatial language. This is typically done in order to gain insight into those concepts with help of the known advantages of diagrammatic representation. In this case, diagrams are just a tool, and the choice of spatial language used to construct them is arbitrary. In that sense, they are used in a conventional way, and so I propose to call them conventional diagrams. What further differentiates them from diagrams of the first class is that when constructing them, we proceed from conceptual analysis of a given mathematical concept to the design of a suitable visualization. I can point at three ways in which conventional diagrams may be constructed. Firstly, by simply rearranging symbols, dots, or other marks, or by coloring them. Examples include Ulam's spiral or Pascal's triangle. Secondly, properties of the investigated object may be translated into a well-known conventional spatial language, such as spatial representations of sets, relations, or functions. Finally, we may devise a completely new way of translating properties of the investigated object into a spatial language, which situation often takes place, for example, in case of computer visualizations. All those uses of diagrams may be thought of as experiments on a broad understanding of the term experiment, as trying out some new method without knowing in advance what the outcome will be. In fact, very often representing mathematical objects in a new way involves trying out different options and then observing and interpreting the result. In case of Ulam's spiral, a new arrangement of numbers has been tried out. In the example with Pascal's triangle, experimenting involved coloring different subsets. And in case of Mandelbrot's set, it consisted in a creative representation of a certain set of complex numbers. In all those cases, the result of such an experiment with representation, may lead to noticing unexpected patterns which require further analysis and interpretation. Thank you for your attention.